Hello, my name is Ridel, and in this video I would like to give a little insight about chemical reactors. And so without any further, let's just get into the video. First of all, what is a chemical reactor? Well, a chemical reactor is a device and most often used in industrial, in which chemical reactions take place. It is generally understood to be a process vessel used to carry out chemical reactions, which is one of the classic unit operations in chemical process analysis. The design of a chemical reactor deals with multiple aspects of chemical engineering. Chemical engineers design reactors to maximize net present value for the given reactions. Designers also ensure that the reactions proceeds with the highest efficiency towards the desired output product, producing the highest yield of product while requiring the least amount of money to purchase and operate. Normal operating expense include energy input, energy removal, raw material costs, labor, etc. Also, energy change can come into the form of heating or cooling, pumping to increase pressure, frictional pressure loss, or agitate. Move on to the reactor equations. So here I got an equation of constant volume batch reactors. So for the special case of constant volume or constant density, usually values for the mixtures and not the reactor. So we can simplify the ideal batch reactor equations starting with the ideal batch reactor equation, where 1 per v squared t to dni per dt is Ri. So the volume is placed inside the differential and changed to concentration, where d parenthesis ni per v squared t per dt is dci per dt is Ri. Constant Vt is ideal batch reactors. This equation is usually valid for liquid phase reactions and for gas reactions where the sum of the stoichiometric numbers equals 0, but it is invalid for the constant pressure gas phase reactions with mole chains. When the rate expression is known, this equation yields the major design variable time for a batch reactions of given concentration or conversion. And there's also types of chemical reactions. First, there is batch reactor. The simplest type of reactor, of course, it's a batch reactor. Materials are loaded into a batch reactor and the reactions proceeds with time. A batch reactor does not reach a steady state and control of temperature, pressure, and volume is often necessary. Many batch reactors therefore have ports for sensors and material input and output. Batch reactors are typically used in small-scale productions and reactions with biological materials such as brewing, pulping, and productions of enzymes. One example of a batch reactor is a pressure reactor. And then the second one, there is SemiBatch Reactor. A semi-batch reactor is operated with both continuous and batch inputs and outputs. A fermenter, for example, is loaded with a batch of medium and microbes which constantly produce carbon dioxide that must be removed continuously. Similarly, reacting a gas with a liquid is usually difficult because a large volume of gas is required to react with an equal mass of liquid. To overcome this problem, a continuous feed of gas can be bubbled throughout a batch of liquid. In general, in semi-batch operation, one chemical reactant is loaded into a reactor and a second chemical is added slowly, for instance, to prevent side reactions. Or a product which results from a phase change is continuously removed. For example, a gas formed by reactions, a solid that precipitate out. The third one, there is CSTR, or Continuous Stir Tank Reactor. In a CSTR, one or more fluid regions are introduced into a tank reactor, which is typically stirred with an impeller to ensure proper mixing of the reagents while the reactor effluent is removed. Dividing the volume of the tank by the average volumetric flow rate through the tank gives the spacetime or the time required to process one reactor volume of fluid. Using chemical kinetics, the reactor expected percent completion can be calculated. The fourth one, we got PFR or plug flow reactor. In a PFR, sometimes called continuous tubular reactor or CTR, one or more fluid reagents are pumped through a pipe or tube. The chemical reactions proceeds as the reagents travel through the PFR. In this type of reactor, the changing reactions rate creates a gradient with respect to distance traversed. At the inlet to the PFR, the rate is very high, but as the concentrations of the reagents decrease and the concentrations of the products increase, the reactions rate slows. Okay, now I would like to give a little overview about the chemical reactors. So, the most common basic types of chemical reactors are tanks, where the reactants mix in the whole volume, and pipes or tubes for laminar flow reactors and plug flow reactors. Whereas reactors in batch process are necessarily operated in a transient state. When a reactor is brought into operation, either for the first time or after a shutdown, it is a transient state and key process variables change with time. Both types can be used as continuous reactors or batch reactors, and either may accommodate one or more solids, reagents, catalysts, or inert materials. But the reagents and the products are typically fluids, liquids, or gases. Reactors in continuous process are typically run at steady state.